Okay, this is the segments and midpoint video. First thing, let's define what a segment is. Segment is basically object has two endpoints, no arrowheads, and it is named by two endpoints with segment notation above. As you will see as we're going on here, when we're talking about the length of a segment, there's no notation above. So looking at this measuring segments, the distance between 2 points, A and B, is written as the length of the segment. Okay, and it's indicated by no notation above the two endpoints. So the length of this segment, if we counted, is 4. If I have two measurements of segments that are the same, so if AB, the length of AB equals the length of CD, then this is written as the segments are congruent. And that little symbol there is a equal sign with a what I call a little squiggly above it. Equal sign with a little squiggly. Okay, you will also see when we say that the segments are congruent, I'm going to draw another picture here. If we do this, and I'm just going to draw them as two separate, you will also see that we will put these little tick marks, and that indicates congruency. All right. Segment addition postulate. So I have this collinear points, right? Collinear on the same line. B, segment or point B is between A and C. Then I can say that the length of AB plus the length of BC equals AC. We're going to use that to complete some examples. So first thing we're going to do is we're going to write down our segment addition that pertains to that diagram. So this diagram, I have PQ plus QR equals PR. And then we're just going to substitute in what we're given. So I can see in number 1 it says PQ is 9 and QR is 28. We're trying to find PR. We add those together. I get 37. In example 2, I'm trying to find PQ, one of the shorter segments. So PQ plus QR equals PR. So when I'm trying to find one of the smaller ones, I'm going to subtract. So PQ equals 4. Now let's try some that are a little bit more involved with some algebra. We have to make sure that we pay attention to what it's asking for. This is just asking for the value of x. So write our segment addition. EF plus FG equals EG. Substitute in our parts. EF is 8x minus 17. FG is 5x minus 3. And EG is 71. Combine like terms. Combine like terms. Combine our variables. Combine our constants. And solve. Divide by 13. X equals 7. So I'd like you to go ahead, stop the video, and try number 6, because number 6 is going to be very similar. Very similar as far as what you're trying to find. You're only trying to find the value of x. So the first thing you need to make sure that you do is write your segment addition. Substitute in x plus 3 in place of CD. 8x minus 9 in place of DE. And just so happens we have an expression for CE this time. Combine. 3 plus negative 9 is negative 6. Subtract 7x from both sides. Add 6 to both sides. Divide by 2. Let that digest. Look at them again. We're going to try the other two. Okay, so now let's look at the next type of problem. The next type of problem we need to look at says find TU. So this time we're going to go beyond just solving for x. So again, let's write down our segment addition postulate. It says that TU plus UV equals TV. Substitute in, TU is 9x plus 2, UV is 5, TV is 14x minus 8. This is just solving an equation now. Combine like terms, 2 plus 5 is 7. Subtract 14x from both sides. Subtract 7 from both sides. Negative 8 minus 7 is negative 15. Divide by negative 5. So I get x equals 3. But again, that's not what I'm trying to find this time. This time I'm trying to find TU. So I need to substitute in to that expression. What is the expression for TU? It's 9x plus 2. So I take 9 times x, which was 3, plus 2. So TU equals 27 plus 2, which equals 29. Okay, number 5 is the same type of problem. Again, I'm trying to find an actual length. So I need to find x first, then substitute in. So what is my segment addition? It's JK plus KL equals JL. Substitute in that first. 27 plus 3x minus 1 equals 5x plus 2. Combine like terms. So I have 3x, 27 minus 1. I would just move x's to the left. Does not matter which one you could always subtract 3x from both sides instead. Then subtract 26. And divide by negative 2. So you get x equals 12. But again, that's not what it's asking for. It's asking for JL. And what is the expression for JL? It's up top here. JL, the expression is 5x plus 2. So JL equals 5 times what x is, which was 12, plus 2. 5 times 12 is 60. So JL equals 62. Okay, on the next page, we have one more example, this segment addition. And in this problem, it's asking for everything. It's asking for everything. So let me zoom in here a little bit. Okay, so look over here to the side. It's asking to find x, then the length of sk, the length of ky, the length of sy. So the first thing we want to do before anything is write down what is our segment addition postulate. It is sk plus ky equals sy. Substitute in 13x minus 5 plus 2x plus 9 equals 36 minus x. Combine like terms first. 15x plus 4. Add x to both sides. Subtract 4. And move it over here. 36 minus 4 is 32. And then divide by 16. So x equals 2. And how do I find sk? sk is it says 13x minus 5, so 13 times 2 minus 5. So that's 26 minus 5 is 21. Ky is 2 times 2 plus 9. 4 plus 9 is 13. And SY is 36 minus X, which is 34. And we can always check. Our postulate says SK plus KY equals SY. So does SK plus KY equal SY? And 21 plus 13 does equal 34. I think what we're going to do is let you practice before we do midpoints. So I would replay this video now, listening and following along with your notes, and then go to the assignment and only do those problems associated with the segment addition, which will be problems 1 through 9.